Hi, I'm Taylor Benedict, a freshman at Sam Houston State University, and I'm currently studying for a degree in biomedical sciences. Now, what does make trig essential for forensics? Ballistics, the study of firearms. Ballistics is used to solve many cases, such as assassinations, where the firearm shootings always tends towards right triangles. This means that using trigonometry, detectives can pinpoint where the projectile originated from. With the model I have set up here, the shooter is meant to be at point A, where the victim is at point B. Angle of elevation and depression. The angle of elevation is a positive angle that stems from the horizon, while the angle of depression is a negative angle that stems from the horizon. So, this blue line is going to be the horizon, and any angle above the blue line to the plumb line will be an angle of elevation, while any angle below the horizon is going to be classified as an angle of depression, where this yellow dot is our victim, and these black dots are our snipers. There are three main trigonomic functions that you're going to want to know to be able to solve a right triangle, those being sine, cosine, and tangent. This graphic up here, SOHCAHTOA, is an easy way to remember the formulas. SOHCAHTOA, standing for sine is equal to opposite over hypotenuse, cosine is equal to adjacent over hypotenuse, and tangent is equal to opposite over adjacent. Now the hypotenuse will always be the opposite of the right or 90-degree angle. Now for the sine function, it is sine of A is equal to the opposite side over the hypotenuse. I use sine of A for all the examples as to not be confusing. The opposite side from A is the one directly across from the triangle. To find angle A using the sine function, you would use A is equal to sine of -1 times opposite over hypotenuse. To find the opposite side using the sine function, you would use opposite is equal to hypotenuse times sine times angle A. To find the hypotenuse, you would use hypotenuse is equal to 1 over opposite times sine times angle A. These three red graphs under each of the trigonomic functions shows what it would look like across 2 pi on a graph. Now for the application and the modeling of a problem. We are given a few bullet points of information to be able to make a model. That being the victim, John Doe, is 6 feet tall, and the bullet entered at the top of his cranium. So that way we can write how tall he was and how far he is off the ground. And a skyscraper is standing 85 feet away from John Doe's body. This way we can write how far the sniper could have been, creating an adjacent angle. The angle of the projectile is 60 degrees from the horizon. The horizon being the adjacent side right here, being the 85 feet. So the angle is 60 degrees. Now we are asked, what is the height of the sniper? Now we can put x as from where the sniper is, past the bottom of the triangle, to the ground. Now we can use mathematics to solve for x. First, find the correct function to use. As we do not have hypotenuse, tangent would be the correct function to use. So we would put tangent of A is equal to the opposite side over the adjacent side. Now we fill in the information that we have. So tangent of 60 degrees is equal to the opposite side over 85 feet. Now we need to move what is in the denominator out to the other side of the equation. This gives us 85 tangent times 60 degrees is equal to the opposite side. This makes the opposite side 147 feet. Now we are not done because this is not where the ground is. We need to account for his height. As stated in our model, he is 6 feet tall, so we will add 6 to 147. This gives us 153 feet is equal to x. In conclusion, understanding trigonometry and how it can apply to the assassination cases is essential as a forensics detective. It can cut down exponentially the amount of time that it takes to find the source of a projectile, as it will not be necessary to search every floor of a building. It also lowers the amount of innocent bystanders that have to have their privacy invaded.